Hey, what's up, guys? Friendly developer here. Today we'll cover these solutions that we talked in the previous video. If you haven't watched the previous videos explanations, I suggest you do. The link is in the suggestion and in description. So without wasting more time, let's start with implementing the solution. So the problem is find the left view of the binary tree. We'll do a level order traversal, and at each level we'll print the first node at that level. So what do? We'll take a queue of integers, and let's add the root node onto the queue. Now we'll continue with the traversal until the queue is empty. While the queue is not empty, we'll continue with solving this problem. Let's get the size of the queue, which denotes the number of elements in that queue at each level. So whenever this line is executed, I'll get the number of nodes in the queue at that point, at that level. So get the size. Now what do? We just print the first element in the queue's front end. We print the first element, and for each element in the queue we add the children of each element to the rear end of the queue. So how do we do that? We'll get the reference, we'll get that node at the front of the queue, and we'll remove that node. Now we add its children onto the queue. We just check if that node has a children or not. If its left is not equal to null, then we push its child onto the queue, rear end of the queue. Similarly, if its right element is not equal to null, push the element, push that node onto the queue. Now this will run for all the number of elements that are there in that level. So when we are at this level, the size of the queue would be 4. So for each of these 4 elements, their children will be added onto the queue. Okay, so this is how we implement the solution. At each level we print the first element in that queue, which is the front of this queue. Okay, now let's submit this, and let's move on to right view of the binary tree. Now similarly we'll do the same thing. I'll copy this. It seems we have a I took a queue of integers. Okay, let's take a queue of nodes of the binary tree. Now queue dot front will give us the node. We have to print its data. Okay, let's solve the same problem for right view of the binary tree. Let me copy and paste this. Okay, so how do we find the right view? We find the right view by printing the last element of the queue at each level. Okay, so this is how we do it. Instead of printing the front, what we'll do is we'll print the last element. How do we do that? Well, if I is equal to size minus 1, then that is how we know we are at the last element. So if I is at size minus 1 position, that means let's say we are at this third level. Now the size of this queue will be 4. When I is equal to 3, then that is the last element in that level. So that is when I print the nodes uh, data. After this, I take that node, I remove it, and I'll add that node's left and right children onto the queue. Okay, let me submit this. Now let's move on to finding maximum node level. The problem is to find the level in a binary tree which has the maximum number of nodes. The root is at level 0. Okay, find the level that has maximum number of nodes. Let me copy the same thing. Uh, anyway, here also we'll take a queue of uh, nodes. I'll push the root element onto this node, and while the queue is not empty, queue dot. While the queue is not empty, I'll continue traversing. The queue becomes empty when we have traversed all the nodes, all the levels. Okay, so I'll take two more variables. One is maximum value. Let's initialize this to minus 999, and the level that we are looking for. Let's start with level 0. Now what do we do? At each level we'll find the number of nodes in that level. We'll get the size of the queue, and if our size is greater than the current maximum value, I'll set the I'll update the maximum current maximum value, and we'll change the level. Okay, so let's take another variable called max nodes level. That will be 0, and at each after each time we look at when we are traversing each level, let's increment this level. So whenever we update the maximum value, our maximum nodes level will be equal to level. Now I'll copy and paste the same. Now we add all the children to the rear end of the queue, so that we proceed to the next level. So once this loop is executed, all the for each node in the current level, we add all their children to the rear end of the queue and remove each of those nodes, so that after this loop is over, we'll only have the elements in the next level in the queue. Okay, so here I just return the level, max nodes level. Now if you take a look at left view, this is accepted, right view is also accepted. Similarly, this is also accepted. Okay, that is how you can implement such problems which use a queue, or which use a level order traversal of elements to get the solution. Hope you guys found this useful. I'm really happy to code the solutions out. It feels awesome to get our hands dirty instead of simply seeing the algorithm. So if you found this useful, please do share, like, and subscribe. Thank you. See you next time. Bye.